Alright, so today we're going to look at graphs that approach infinity. So the first one, it says use the graph of f of x equals x cubed minus x squared minus 4x plus 4 to describe its end behavior. Support the conjecture numerically. So let's do the first one. Okay, here we just want to look at so use the graph. So just looking at the graph, what does it look like at the end behavior? So the end behaviors are as the x approaches negative infinity. So negative infinity is over here, right? As x approaches negative infinity, and as x approaches positive infinity. All right, so we want to see what the graph is doing there. So just looking at the graph itself, as it keeps going to the left, as it approaches negative infinity, what is it doing? It's going down, right? The f of x is approaching negative infinity. Keeps going down and down. So here looks like the f of x is approaching negative infinity, right? Because it's going down. And then here, the other end, as x approaches positive infinity, it looks like f of x is approaching positive infinity as well. So we would just write that as x approaches negative infinity, okay? Or a way of thinking about this is as x goes to the left, as x goes to the left forever, f of x approaches negative infinity. So as it goes to the left, the y keeps going down forever. And as x approaches positive infinity, f of x approaches positive infinity as well. Okay, so as x goes to as you go to the right, the graph keeps going up forever. Okay, so that's what this is. As x goes to the right forever, the graph goes up forever. F of x up and down, x left and right. Alright, so the next thing it says is to support the conjecture numerically. So we want to make a table for this one. And this one we're going to need to use a calculator. Alright, so we have x and f of x over y. Alright. And we're going to use some pretty big numbers. Alright, and one number in the middle, we're going to use 0, just for the 0. Okay, if we plug in 0 here, 0 cubed is 0, minus 0 squared is 0, minus 4 times 0, which is 0, plus 4. So we get 4 there. Ta-da! Alright. Now, here, because we're looking for when x goes to negative infinity and positive infinity, we want really big numbers and really small numbers. So let's use 1,000 for big and 10,000 for really big. X approaches positive infinity. Okay, so it's not even close to infinity, but it's going there. It's pretty big. And same thing, just negative. So negative 1,000 and negative 10,000. Alright, so that way it's approaching, x is approaching negative infinity. Alright, so let's plug those in. So I'll just do one of them and then we'll use the calculator for the rest. So f of, and the first one, let's do negative 10,000. Is equal to negative 10,000. And this is how we're going to write it in the graph. So if you're using a scientific calculator or desmos.com/scientific, then yeah, make sure you write it out correctly. Minus 4 times negative 10,000 plus 4. Alright, so let me show you how to write that in the calculator. It's blurry. There we go. Okay. There we go. So we want to put parentheses and then negative, sorry, 10,000 first, and then negative. Yeah, we need the parentheses because it is a negative number, and we're cubing it. So here our cubed is, we have to hit shift because it's yellow. You see that? So shift, cubed, and then minus, and then parentheses again, 10,000, negative, close parentheses, square it, minus, and then this one, we had to put parentheses around the 4 and the negative 10,000. So minus parentheses 4 times 10,000 negative close parentheses plus 4 and equals. Ta-da! We get negative 1.0000996 to the 12th power. Is that negative 12? Yeah, to the 12th power. Okay, so it's pretty big. And it's negative a really big number, so it turns out to be a really small number. So we would write that as negative 1.00. Now we don't need to put that 00, but we usually put up to the 100th place when we're doing scientific notation, times 10 to the 12th. So very big, and since it's negative, that means it's very small. Okay, so now I'll pause it, and then I'll do the rest in the calculator. And there we have it. So we have, as x gets smaller, as x goes to the left, the y is getting very, very, very small. It goes from 4 to a negative 1 times 10 to the 9th, just small, very small, and then it goes to negative 1 times 10 to the 12th, which is very, very, very small. So it approaches negative infinity, okay, as you get smaller, as you go to the left. And as you go to the right, it's approaching positive infinity. And that's how you show it numerically.